Continuing with our revision on making the subject of the formula, we shall look at some more examples and see how best we can do this topic. So if we look at an example given that if s equals to root, if our s equals to the root of kd into 1 minus d, they're telling us to express L in terms of, so express L in terms express L in terms of d, k and s. So in other words, this question is requiring us to make L the subject of the formula. So what shall we do to make L the subject of the formula? Looking critically, L is being bound into a square root, then enclosed in a bracket. So we have to make sure that we make L stand independent on each side. So ideally, how we can go about this, we can ideally first remove the square root by squaring both sides. Since we are being given that our s equals to the root of kd into L minus d, so we can first of all square both sides. Square this, also square this, also square this side. So the square here cancels out with the square root, so this becomes s squared. This becomes s squared equals kd into L minus d. So that's what we are having. Then remember, we want to make L the subject of the formula, so it's ideally we can remove this, since here there is a multiplication between these two. So I can just divide both sides by kd, so that I remove the kd from this side. Even this side I will divide it by kd into L minus d. So the kd and the kd will cancel out. I remain with s squared over kd will give me my L minus d. So making L the subject, I will make d cross the equal sign, and since it is carrying a negative sign, keep in mind that always the sign comes different number, so it is our d which is a negative. When to cross the equal sign, it becomes a positive. So we shall have s squared over kd plus d will equal to our L. So you can even stop here. You have made L the subject of the formula, therefore our L will equal to s squared over kd plus d. So we have simply made our L the subject of the formula. So given another example, we have said given that our root, and this is the fourth root we are talking of today, equals to px squared plus a equals to I. So for this case, they want us to express x in terms of a, I and p. So here they want us to express x in terms of I, a and p. So in other words, they want us to make x the subject of the formula, and they're saying hence find it. They want us to find hence find x when a equals to 4, p equals to 4, and I equals to 1, and our I is equivalent to a 1, to a 1. So that is the question we are being given. So they want us to make x the subject of the formula, and since x is bound into a fourth root, the only way of removing a fourth root, make sure we shall multiply, like we shall have that fourth root being removed by having power 4 on both sides. So I'll have this side raised to power 4 and the other side raised to power 4, so that we shall aim at that fourth root. So ideally I'll have, that is the question they have given us. So for us to remove this fourth root, shall have raised to power 4 on both sides. So they have given us that the fourth root of px squared plus a equals to I. So that is the question they have given us. So according to our question, that's what they have given us. So we shall have raised to power 4 both sides. So I'll have power 4 both sides. I'll raise both sides raised to power 4. So this is the fourth root of px squared plus a equaling to I. So I'll raise both sides raised to power 4. So the power 4 cancels out with the fourth root, remaining the px squared plus our a equals to I raised to power 4. So what do we have here? We take a the other side, remain with the px squared equals to I power 4 minus a. So the a has crossed the equal sign, as ideally become a negative. So the our has ideally become a negative. So we shall have both sides being divided by p equals to I power 4 minus a, also divided by p. So the p cancels out with this p. We have x squared will equal to I raised to power 4 minus a over p. So making x the subject, we have to take the square root both sides. So we take the square root so that we eliminate the squared. So the only way of removing that squared from x is by taking a square root on both sides, so that the square will cancel out with the square root. So we ideally make x the subject of the formula. So our x will equal to I raised to power 4 minus a over p. But there was a hence part. They want us to find the x when a is 4, p is 4, and the I is 1. So our I was 1. So we substitute where we see this I, we put there a 1 raised to power 4 minus the a is a 4 over our p, which is also a 4. So 1 raised to power 4 is 1 minus again 4 over 4. So we have 1 minus 4, which is a negative 3 over 4. So that is the final answer for x. So therefore our x will ideally be negative 3 over 4. So that is done with that. No further revision. So we can have simply another example concerning making subject of the formula. So I want you in this expression to make y the subject of the formula. For example, you have given us that x equals to y squared plus 1, x equals to y squared plus 1 over y squared minus a 3. So they want us to make y the subject of the formula. Let me just indicate it here in brackets, implying that we are making y the subject of the formula. Simply here we shall first cross multiply. So since it is an equal sign, I will only cross multiply this and this, then this and that. So we have x into y squared minus a 3. This bracket I'm putting is simplifying multiplication of x, and this downward expression equals to 1 times that, which will be the same, y squared plus a 1. So this is x times this, we get xy squared. X times negative 3, we get negative 3x this will give us a y squared plus a y plus a 1. You remember they told us to make y the subject of the formula, and I'm seeing two aspects containing y with degree 2, that is y squared. So I have to make sure I put those y squareds together. How? Bring this side and take this the other side. Make sure whenever any element is crossing the equal sign, it changes the sign. So this y, which is a squared, crossing this side becomes a negative. So it becomes xy squared. I bring this it becomes minus a y squared equals 1. Then I will take this negative 3x, this side, it becomes a positive 3x. Here I can just simply factorize out the y squared. So I'll have y squared into x minus 1 equals to 1 plus 3x. So from here I can divide both sides by x minus a 1. So simply when you multiply this, you come back to this. This times this, you get that. This times this, you get that. That I've just simply factorized out the y squared. Since that we can have one aspect of y. So whenever you have two aspects, make sure you first bring them together, you factorize out so that it becomes 1. So this will equal to 1 plus 3x. Is it okay? Then I will divide both sides by 1 minus x. Even this side I divide by 1 x minus 1. So we have y squared equals, you can even begin with the unknown, 3x plus 1 over x minus 1. But they wanted us to make y the subject. So for us to make y the subject, we shall just take the square root on both sides to remove that squared. This is 3x plus 1 over x minus 1. The square goes with the square root. So our y, take a square root on both sides, will equal to the root of 3x plus 1 over x minus 1. So we have simply made the y the subject of the formula. So there's also another simple example we can look at. This is another example we can look at, the example 4, which says root of y plus a over root of y minus b equals to a k. They still want us to make y the subject of the formula. So what shall we do? Simply we are seeing two aspects of y which is being bound into a root. The first step, so this is an indication that I'm making y the subject of the formula. I never wanted to write all the words. I've just said this equals this. So this bracket, I'm indicating that I'm making y the subject of the formula. Simply also the first step here will be a cross multiplication. This multiplied by this multiplied by that. So 1 times that, it will remain the way it is, root of y plus a. So this times this, it will become a k into root y minus a b. So root of y plus a equals this times this, that is k root of y minus k b. So these aspects containing y, we shall bring them together, then this a will go the other side. Or what we can do, we can bring this side, and this aspect of y we take it this side. So I'll bring this way, and I take the y the other side. So bring this becomes the positive. So I'll leave the a here, shall leave this a here. I bring this one, it becomes the positive, plus kb equals, so leave this side, k root y, bring this root y, it becomes a negative minus a root y. From there we shall have to factorize out that y. So we had, ideally, it was a plus kb equals to k root y minus root y. That's what we are having. So we shall simply factorize out that root y, pull out the root y, you factorize it. Here will remain with the k here. Here, since we have pulled out the root y, we shall remain with negative 1. So the next step is dividing this and remove it from this side. You remember, we want to make y stand independent. So I'll have to divide both sides now by k minus 1. This will also equal to root y into k minus 1. Then you also divide by k minus 1. So the k minus 1 here will cancel out. I'll remain with my root y, which is standing here, equivalent to a plus b over k minus 1. I've just brought this one as this. Now I've taken this one as this. So the only way of removing that root is by squaring both sides. Even this side you square it, a plus b over k minus 1, you also square it. So the square dies the square root. Our y will just simply be a plus b. You can leave it like this, or you can leave it as above there. So that will be our y. We have simply made our y the subject of the we have made our y the subject of the formula. So that is our y. We have made it the subject of the we have made our y the subject of the formula. So that is simply how we can make expressions. I don't think it is all that tough. So I can look at another example where they want us to make r the subject of the formula. So in this example, we shall make r the subject of the formula. Example 5, given that 1 over r equals to 1 over r1 plus 1 over r2. They want us to make this r the subject of the formula. So what we shall do, we shall cross multiply. To get the LCM, we cross multiply it up. So the LCM will be r times r1 times r2. So multiply the LCM throughout, times r1 r1 r2 equals 1 over r1 times r1 r2 plus 1 over r2 times r1 r2. So we find that this r crosses out with this r1 goes with r1, r2 goes with r2. So remain with r1 r2 will equal to r2 plus r1. So we're having this r and that r. So we have to factorize out the r. We pull out that r, we remain with r2 plus r1. So we have factorized out that r. The next step will be dividing both sides by r1 plus r2. Even this side we divide by the same thing, r2. This is r2. We also divide here, r2 plus r1. So this cancels out with this. Then we shall have our r standing independent. Our r will be r1 r2 over r2 plus r1. We have simply made our r the subject of the formula. So number 5, they wanted us to make r the subject of the the subject of the formula.